Hi everyone, this is part 2 of the College Mathematics 1A revision for examination. The first question, consider the cubic function fx equal 2x cubed plus 5x squared plus x minus 2. Using the factor theorem or otherwise, find all the factors of f of x. So the first factor is not present. So we need to find what is our first factor. So a question like this, always check to see were you given the first factor. In this case, you weren't. So we have 2x cubed plus 5x squared plus x minus 2. And I am going to think of all the factors of the last number. It's going to be plus or minus 1, plus or minus 2. And now we have to try to see which one of them will give us 0. So when I substitute x equal 1, will that give me 0? So I put 1 here. So I have 2, 1 cubed plus 5 times 1 square plus 1 minus 2. And just by looking at this will not give me the factor. So therefore it's not 0. So I need to try another number. Let's try x equal negative 1. So I have 2 open bracket negative 1 cube plus 5 open bracket negative 1 square plus minus 1 minus 2. Negative 1 cube, that's minus 1. So minus 1 times 2, that's negative 2. Negative 1 square is 1, so 1 times 5 is 5. Then you have minus 1 minus 2. So minus 2 plus 5, that's 3. 3 minus 1, that's 2. 2 minus 2 is 0. So that means we can have our first factor. So if I carry the 1 over the equal sign, what this is saying is that x plus 1 is a factor. Now I am going to use the x equal negative 1 to divide the polynomial. So I put the minus 1 on the outside. Remember the order is x cubed, x squared, x, and a constant. So we're going to take the coefficient. So the coefficient of x cubed is 2. The coefficient of x squared is 5. The coefficient of x is 1. And my constant is minus 2. So the first step is that I carried on the number. Then I multiply 2 times negative 1, that's negative 2. Then I add 5 plus negative 2, that's 3. Then 3 times negative 1, that's negative 3. Then we add 1 plus negative 3, that's negative 2. Then multiply minus 2 times minus 1, that's positive 2. And then add to get my remainder, which is 0. So this becomes a quadratic, which is 2x squared plus 3x minus 2. And now we need to factorize. So we have to use the AC method where I multiply 2 times negative 2. That gives me negative 4. So we need two numbers that multiply to give me negative 4. But when I add, I will get the positive 3 that's in the center. So what are those two numbers? Two numbers that multiply to give me negative 4, but add to give me 3. I'm hoping you're seeing positive 4 and negative 1. So positive 4 times negative 1 gives you negative 4, and positive 4 plus negative 1 is 3. So we have 2x squared plus 4x minus 1x minus 2, and then we group. What can we factor out? We can factor out 2x. So if I factor out 2x, I'm left with x. Factor out 2x, I'm left with 2. What can I factor out? Factor out minus 1, so I'm left with x plus 2. So therefore we have 2x minus 1. We have x plus 2. And the final one, it's coming from the first factor, x plus 1. And that's it. Now, some persons learn to solve the system of equation using the cofactor method. Some persons use the diagonal method. So I'm going to use both methods. So first thing first, we are going to take the coefficient of the variable. So going ahead, we take the coefficient of x, so it's going to be 3, 1, 2 to create a column. Take the coefficient of y, so I have 2, 2, 1. And then the coefficient of z, I have minus 1, 1, 1. Now, to find z, it's going to be the determinant of the z over the original determinant. And just know that this is the x column, the y column, and this is the z column. So let's use the cofactor method to find the answer. So we're going to find the original determinant. And to find the original determinant, I'm going to find the determinant of this 3 by 3. So the determinant of this is equal to, I have my 3, then we remove the first row and the first column. Let me go ahead and use something to remove it. Remove the first row and first column. I have my 2 by 2 matrix, which I'm going to write. So we're going to have 2, 1, 1, 1 minus, don't forget the center 2. So we take the first row, which is 2. And then once again, remove the first row, the middle. So we're going to have 1, 2, 1, 1. So we have 1, 2, 1, 1. And then plus. Then we're going to remove, we're going to take this minus 1. And then we are going to remove the last column and the first row. So I have 1, 2, 2, 1. Now we would have the number 3. Then it would be 2 times 1 is 2, minus 1 times 1 is 1, minus 2. Then 1 times 1 is 1, minus 2 times 1 is 2. This becomes minus 1. And then we have 1 times 1 is 1, minus 2 times 2, that's 4. So just to repeat, we take the numbers 3, 2, minus 1, 3, 2, minus 1. Then we know this is plus, minus, then plus. Then I remove the first row, first column to get this 2 by 2. Then the first row in the center column to get this 2 by 2. And the first row, last column to get 1, 2, 2, 1. Now find the determinant. So we multiply 2 times 1 is 2, minus 1 times 1 is 1. 1 times 1 is 1, minus 2 times 1 is 2. 1 times 1 is 1, minus 2 times 2 is 4. Simplifying further, we have 3. 2 minus 1 is 1, minus 2. 1 minus 2, that's negative 1. Minus 1. 1 minus 4 is negative 3. So this is 3 times 1 is 3, plus 2, plus 3 because negative times negative positive, negative times negative positive. So this is 8. Now we are going to find the value of z. So if you're finding the value of z, you remove this column and replace it with 11, 4, and 5. If I was finding the value of y, I would go back to the original matrix and remove the center and replace it with 11, 4, 5. But because I'm finding z, I will replace the last column. So I still have 3, 1, 2, 2, 2, 1. But the last column, I'm going to have 11, 4, and 5. So I'm going to find the determinant of this, but let me just put it on a different page. So looking at this, I'm finding the determinant of z. So to find the determinant of z, I am going to have my first row, which is 3, 2, and 11. Then we know this is plus, minus, then plus. Now I need to get my 2 by 2 matrix. So remove the first row. So this is removed. And now I'm going to remove the first column. So I just have 2, 4, 1, 5. So I'll have 2, 4, 1, 5. Still remove the first column, but now the center. And I'll have 1, 2, 4, 5. So I'll have 1, 2, 4, and 5. Then I remove the last column. So I'll have 1, 2, 2, 1. So find determinant of the 2 by 2. I will say 5 times 2 is 10, minus 1 times 4 is 4. Minus 2. Then we have 1 times 5 is 5, minus 2 times 4 is 8. Then we have plus 11. Then we have 1 times 1 is 1, minus 2 times 2 is 4. So therefore we have 3, 10 minus 4 is 6, minus 2, 5 minus 8, that's negative 3, plus 11, and 1 minus 4, that's minus 3. So 3 6 is 18, this will be positive 6, and this would be minus 33. So we have 18 plus 6, that's 24, minus 33, equal negative 9. So now to find z. So the determinant, so z is equal to minus 9 divided by 8. Now the next method is using the diagonal method, and what we are going to do is once again create a 3 by 3 matrix. So this is another way that we can do this. So we have 3, 1, 2, this is a coefficient of x, 2, 2, 1, which is a coefficient of y, minus 1, 1, 1, it's a coefficient of z. So to find the original determinant, so just as before, we need the determinant of z over the original determinant. And the original determinant is just finding the determinant of this matrix that I have. So what we're going to do, we're going to have 3, 1, 2, 2, 2, 1, negative 1, 1, 1. And then we take the first two columns and we write it on the outside, which is 3, 1, 2, 2, 2, 1. Now let's go ahead and find the determinant. So I'm going to multiply 3 times 2 times 1. 3 times 2 times 1 plus, then 2 times 1 times 2. So we have 2 times 1 times 2 plus negative 1 times 1 times 1. So we have negative 1 times 1 times 1. Then we are going to look at the other ways. I have minus. Then multiply 2 times 2 times negative 1. Plus, then we multiply 1 times 1 times 3. So 1 times 1 times 3 plus it's going to be 1 times 1 times 2. So it's 1 times 1 times 2. So therefore we have 3 2's 6 plus 2 times 2, that's 4. Because the 1 doesn't affect anything, that's why I'm not saying 2 times 1 is 2. So minus 1 times these 1 is going to be minus 1. Minus 2 times 2 is 4 times this is going to change it to minus 4. 1 times 1 times 3, that's 3. And this will multiply to give me 2. So working this out, we are going to have 6 plus 4, that's 10, minus 1, that's 9, minus 4 plus 3, that's negative 1, and negative 1 plus 2, that's 1. So we have minus 1 to give me 8, which is the same as the previous method that we used. Now we need to find the determinant of z, so we have to remove the last column and replace it with 11, 4, and 5. So this is the matrix. So therefore, if we remove this and replace it with 11, 4, and 5, we are going to create the determinant of this matrix, this 3 by 3 matrix. So we're going to have 3, 1, 2, 2, 2, 1. So we're going to find a determinant of z. So multiply 3 times 2 times 5. So we have 3 times 2 times 5 plus 2 times 4 times 2. So we have 2 times 4 times 2 plus 11 times 1 times 1. So we have 11 times 1 times 1. Now we're going to have minus the other direction, 2 times 11. So we have 2 times 2 times 11 plus, then we're going to have 1 times 4 times 3. So we have 1 times 4 times 3. And finally, plus 5 times 1 times 2. So 5 times 1 times 2. So 5 times 1 times 2. So therefore, what we have, 3 is 2, 6, 5, 6 is 30, 4 2 is 8, 2 8, 16, and in the last bracket, you multiply to get 11. Minus the next, we have 2 2's 4 times 11, that's 44. For the next part, 4 3 is 12, and 5 2 is 10. So we have 30 plus 16 plus 11, that gives me 57 minus 44 plus 12 plus 10, that gives me 66. So 57 minus 66, that gives me -9. So that means the value of z is equal to the determinant of z over the original determinant. So therefore, I will have -9 over 8. And that's it. Now for this question, expand and simplify, we have two methods that we can use. We can use the binomial theorem, or we can use the Pascal triangle to expand. So first, I'm going to use the binomial theorem, and then I am going to use Pascal triangle. So for the binomial theorem, it goes like this: NCR A n minus r BR. So for the case of having space, I'm going to expand this a little bit more. Now, let me list out what is A. So A is 3x. B is -4. And then n is a power, so n is 5. And r, we start at 0 and we stop at 5. So you have 0, 1, 2, 3, 4, and then we have 5. So I'll have r is equal to 0, then r is equal to 1, then r is equal to 2, r is equal to 3, r is equal to 4, and then r is equal to 5. So replace n to be 5. So I'll have 5c r is 0, so I'll have a 0 here. What's my a? Is 3x, so I'm going to have my 3x here. And then what's my power? N minus r, so n is 5 and r is 0. What's b? Our b is -4, so I replace b to be -4 and r is 0. So that's my first part that I have done here. Now we're going to do this again, but we're going to substitute, and the only thing that changes is r. All right, so let's look at when r is equal to 1. All you're going to do is replace the zeros to be 1. So I am going to have, instead of 5c0, I'm going to have 5c1. Then we have 3x, 5 take away 1, and then -4 to the 1. Plus r equal 2, so I have 5c2. Then I have 3x, 5 take away 2. Then we have -4 raised to the power 2. Plus r equal 3, I have 5c3. Then we have 3x, and instead of 5 take away 2, I have 5 take away 3. And then -4 raised to the power 3. Plus, then we have 5c4, 3x, 5 take away 4, -4 to the 4. Plus, finally 5c5, 3x, 5 take away 5, -4 to the 5th. So now simplify. So the 5c0 you have to put in your calculator. So 5 NCR 0, you enter in your calculator, you will get 1. For the 3x now, this is 5 take away 0. So 5 take away 0 is 5. So that means I have 3x to the 5th. So we know 3 to the 5th is 243. So this is going to be 243. And then the x will also have the power of 5. Now, anything raised to the power of 0 is 1. So this will be times 1. Now we have to enter 5C1. So 5 NCR1, that's 5. So I put a 5 here. Then 5 take away 1, that's 4. So this is 3 to the 4th, that's 81. And then we're going to have the x being raised to the 4th, so that's x to the 4th. Minus 4 to the 1, that's negative 4, so I'll have a negative 4 here. Now 5C2, we are going to have 5 NCR2, so that's going to give you 10. So we have a 10 here, but 5 take away 2, that's 3. So 3 cubed, we know it's 27, so I have my 27. And the x is also sharing the power, so it's going to be x cubed. Negative 4 squared, that's 16, so I have times. So it's times 16. Remember, when you square a number, it becomes positive. Now we're going to 5C3. So 5 NCR3, that's 10. So I have 10 here. And 5 take away 3, that's 2. So squaring this is going to be 9x squared. Minus 4 cubed. So minus 4 cubed, that's minus 64. 5C4, that's 5. So I have my 5 here. And then we have 5 take away 4, that's 1. So 3x to the 1 is 3x. Minus 4 to the 4 is minus 4 to the 4 is minus 256. 5C5, that's 1. 5 minus 5 is 0, and anything raised to the power of 0 is 1. Minus 4 to the 5, that's minus 1024. So something I need to note is that when you have an even power, your number is going to be positive, but when you have an odd power, your number is going to be negative. So multiplying the first bracket, we have 243 x to the 5. We have to multiply 5 times 81 times minus 4. So that's minus 1620 x to the 4th. Then we have 10 times 27 times 16. That's 4,320 x cubed. Then we have 10 times 9 times minus 64. That's going to be minus 5,760 x squared. Then we have 5 times 3 times minus 256. That's minus. So this correction, let me correct it. There is a correction. This should be positive. So I just got it. So just to correct, I stated in the video that when you have an even number, it's supposed to be positive. So correcting that error, this should be positive 256, which I've corrected. And therefore, this is going to be positive 3,840x and then minus 1024. Now we can also use Pascal triangle. So Pascal triangle, we have 1, 1, 1, 1, and 1 plus 1 is 2. Then we put another 1. 1 plus 2 is 3. 2 plus 1 is 3. Then we have another 1. 1 plus 3 is 4. 3 plus 3 is 6. 3 plus 1 is 4. Then we have another 1. So 1 plus 4 is 5. 4 plus 6 is 10. 6 plus 4 is 10. 4 plus 1 is 5. So we use this when we have the power square. This when we have the power cube. When we have the power to the fourth. And this is when we have the power to the fifth. And given that this is to the power fifth, these are the numbers I'm going to use. 1, 5, 10, 10, 5, and 1. Then I'm going to put some plus and put these in brackets. So I have my, and put plus, put this in bracket, plus, put this in bracket, plus, put this in bracket, and plus, put this in bracket. Now, A is still the first term, so we have A, which is 3x, and B is negative 4. So what we're going to do for the first term, we are going to start at 5, and then we decrease. So we have 3x, and it's going to raise to the 5th. Then we're going to have 3x, and then it's going to raise to the 4th. Then we have 3x, and it's going to raise to the 3rd. Then we have 3x, then it's raised to the 2nd. Then we have 3x raised to the 1. And finally, 3x raised to the 0. Then we're going to move on to the next term, which is negative 4. And we are going to have to increase. So we start at 0 and increase. So it's going to the 0, then negative 4 to the 1, then negative 4 to the 2, then negative 4 to the 3, then negative 4 to the 4, and negative 4 to the 5th. So the first term, you start at 5 and you decrease, while the second term, you start at 0 and you increase until you reach this number. So let's simplify. We have 1 times 3 to the 5th. We established from the previous activities 243. So this is 243. And then this is x to the 5. 4 to the 0, that's 1. So that's going to be times 1. Then we have 5. 3x to the 4th. So 3 to the 4th is 81. Then we have x to the 4th times negative 4 to the 1. That's minus 4. Plus, we have 10 times cubing this is going to be 27x cubed, and negative 4 squared, so that's positive 16. And then we have 10 3x squared, so that's going to be 9x squared, and negative 4 cubed. So you're cubing that, but guess what? The sign is going to remain, so that's going to be minus 64. and then we have plus 5 times 3x. And this one, because it's an even power, when you raise it to the power of 4, it's going to become positive. So I have positive 256. And then we know that anything raised to the power 0 is 1, so times 1. And negative 4 to the 5, so once again, it's going to remain negative. So negative 4 to the 5 is 1024. So multiplying, we have 243 x to the 5th. We have to multiply 5 times 81 times negative 4. So that's minus 1620 x to the 4th. And then we have 10 times 27 times 16. That's 4,320 x cubed. Then we have 10 times 9 times 64, and the sign is minus. So that means I am going to have negative 5,760 x squared. Then we have 5 times 3 times 256. That is 3,840 x. And then multiplying this to give you minus 1,024. That's it. Here we're going to evaluate the following. Now note that the bases are not the same. So because they're not the same, we have to log both sides. So I'll have log 2, 3x, take away 4, equal log 5. Then we carry the power in front. So we have 3x, take away 4, log 2, equal log 5. Then we divide both sides by log 2. And this cancels, so we have 3x, take away 4, equal log 5 over log 2. And now log 5 over log 2, you can put that in your calculator. Log 5 divided by log 2, and that will give us 2.32. So we have 3x, take away 4, equal 2.32. Carry the 4 over. So we have 3x equal 2.32 plus 4. Now 2.32 plus 4, that is 6.32. Then we have our 3x. Then divide both sides by 3. So this cancels, so x is equal to, so 6.32 divided by 3, so that's 2.11 or 2.1. Next, we have one log on one side and a number on another side, so we write it in exponential form to solve it. So writing it in exponential form, we're going to have 3x take away 2 equal 2 is the base and 3 is the power. 2 to the 3 is 8, so I'm going to have this to be 8. Then carry over the 2, so I have 3x equal 8 plus 2. So 3x is equal to 10. then divide both sides by 3. So x is equal to 10 over 3. Now here you have log base 3, 3x plus log base 3, 4 equal 2. So with log, when you add, you multiply. So you write the log once with the base. Then you multiply 3x times 4. So it's going to be 3x multiplied by 4 equal 2. So 3, 4 is 12. So this is log base 3. This is 12x equal 2. Then write it in exponential form. So we have 12x equal 3 is the base, 2 is the power. So we have 12x equal 3 squared 9. Then divide both sides by 12. So x is equal to 9 over 12. Now, both 9 and 12 is divisible by 3. So we can reduce it to be 3/4 or 0.75. For this activity here, we have, if you look at this, the bases can be the same. 2 to the 3x, take away 4, equal 2 to the 2. So drop the base and equate the powers. So I have 3x, take away 4, equal 2. Then I carry the 4 over, so I have 3x equal 2 plus 4. So 3x equals 6. Then divide both sides by 3. So this cancels, so x is equal to 2. The next one, we have two ways that we can look at it. One way is to divide both sides by 3. So divide by 3, so I have 9 to the x plus 1. 81 is divisible by 3, so that's give us 27. And then 27 can be in base 3. So we have 27 is 3 to the 3. And then 9 is 3 squared. Then we multiply by 2. So this is going to be 3 to the 2x plus 2 equals 3 to the 3. So we drop the base, equate the powers to be equal. So I have 2x plus 2 equals 3. Then carry the 2 over. So I have 2x equals 3, take away 2. So 2x is equal to 1, and then divide both sides by 2, so x is equal to 1/2. Another way that persons would do this question, let me do it in the center. So we have 3 times 9 to the x plus 1 equal 81. So we know 81 is 3 to the 4th. We also know that 9 is 3 squared. And then we distribute the 2 times x and 2 times 1. So this is 3 to the 1 times 3 to the 2x plus 2 equal 3 to the 4th. So write the base ones and add 1 plus 2, that's 3. So this is 3 plus 2x equal 3 to the 4th. So you drop the base and equate the powers to be equal. So you have 3 plus 2x equal 4. Then carry the 3 over. So I have 2x equal 4 take away 3. So 4 take away 3 is 1. So I have this to be 1. And then divide by 2. So x equal a half. The final question is amortization. And this is the formula for amortization, which is given in the exam. X is the value for each payment needed to amortize a loan into years. P is the principal. R is the interest rate. N is the amount compounded. And T is the years. So we're going to look at a question that requires us to use this formula. So I'm just going to put it here. Amy borrowed $80,000 to buy a house. The interest rate charge is 8.5% compounded monthly. How much is the monthly payment if this will be done for 25 years? So amount borrowed will be the principal. So the principal is 80,000. R is 8.5%, but converted to decimal, you have to divide this by 100. So R becomes 0.085. So in this case, I'll have 0.085. Any so is compounded, and they say monthly. Monthly is 12, so I'll have over 12. Then in the denominator, I am going to have 1 minus 1 over 1 plus R over N, so that's 0.085 over 12. And NT, so N is how it's compounded, 12. And T is the years, it said 25 years. So when working this out, let's look at the numerator. We have 0.085 and divide it by 12. And I'm going to round it off. So some calculators, if you look on your calculator, some calculators give you as standard form, which is mine, 7.083333 times 10. If you look at the top, it's a -3. So this is in standard form. Not all calculators do this, but if you have a calculator like mine, ensure you see the times 10 to the -3. You are going to move the decimal point 1, 2, 3 places to the left and add some zeros. So that means this is 0.007083. So therefore, I'm going to have 80,000 times 0.007083. And I decided to use that amount of numbers. You don't have to. You could have just said 0.007. That's fine. Just ensure you round off properly. So in the denominator, I have 1 minus 1 over. This is going to be 1 plus 0.007083. Because this is the same thing. So that's why I have this to be 0.00783. And 12 times 25, that is 300. So I have raised to the 300. In the numerator again, we have 80,000. And you multiply it by 0.007083 to get $566.64. In the denominator, I have 1 minus 1 over. This will be 1.00703 raised to the 300. And now I can put this part in the calculator. Just put 1 divided by 1.007083 raised to the 300. So when you put that in a calculator, let me write the 566.64. You'd have 1 minus 0.12. So 566.64. And then you do 1 minus 0.12. That would be 0.88. And finally, the monthly payment, you'd see 566.64 divided by 0.88. And the monthly payment would be $643.91. So that's what you'll be paying for 25 years. And that's how you calculate the monthly payment for the loan. Thanks for watching, guys. Don't forget to like and subscribe to my channel. Have a great day.